Good afternoon and welcome to the 2018 New England Greenhouse webinars. My name is Jeffrey Dewar from University of Massachusetts Extension, and this webinar series is a collaborative effort of UMass Extension, University of Connecticut Extension, and University of New Hampshire Extension, and is sponsored by Sungrow Horticulture and Blackmore Company. The theme of the webinar series is Growing Healthy Roots. The title of the webinar today is Using Mineral Nutrition to Prevent Root-borne Pathogens, and our speaker is Dr. Wade Elmer, who is a research scientist with Connecticut Agriculture Experiment Station. If you have any questions during the webinar, please type the question on the question box, and at the end of the webinar, Brian Dixon will answer the question. Will read the questions, and Elmer will answer the questions. After the webinar, there will be a short survey. Please complete the survey before exiting the webinar. Before I pass the controls to Elmer, I'd like to mention that the recordings of the webinars are posted on the UMass Extension Greenhouse and Horticulture Program website. At this point, I'd like to pass the controls to Elmer to continue with the webinar. Elmer, it's yours now.
Okay. Can you see my screen now, everybody?
Not yet. Show your screen first.
Okay, show my screen.
Yeah, okay, yeah, it's great now.
Okay. Okay, well, thank you. I'm Wade Elmer from the Connecticut Ag Experiment Station, and what I want to try to talk to you today is about how we can use mineral nutrition to tweak our disease management strategies here. This is an area I've been involved in for quite some time, so I'll look forward to questions, and of course you can contact me on our webpage later on if you have another question that comes up later on. First thing I always ask is why is fertilization such an important strategy? Well, first of all, it's already something that we're doing. We're not asking growers to go out and put out another application or to come up with a new type of potting strategy or a new type of mix or something. We're going to be fertilizing our crops regardless. So we're finding that simple changes in fertilization can result with increased resistance to disease. Sometimes this is just tweaking the nitrogen form. One of our major obstacles is that ornamental crops can vary in their response to fertilization and to disease, and this is a problem because many times every crop and disease need to be studied individually. I always like to talk about the disease triangle as a way of talking about how nutrition can affect disease. There's three things you need to have a disease. You have to have a plant that's susceptible, a pathogen has to be present, and then there has to be an environmental influence. And we find that nutrition, for the most part, really affects the plant, and it causes the plant to have the building blocks it needs to create defense products to prevent infection. And that's one of the major reasons. But it also has a strong effect on the environment by changing the pH and the response of the roots to the various nutrients and such. And then lastly, it can also affect the pathogen. There's not a lot of influence of nutrition directly on the pathogen, but there are a few examples. So for the most part, it's towards the plant and the environment. Now, years ago, I was involved with a project. We wrote a book on mineral nutrition and plant disease. And I've gone through there, and I recently counted 475 articles on different systems and so forth, and how nutrition could affect disease. And less than 10% of them had to do with ornamentals. So we're really in need of information as to how disease can be manipulated with nutrition in ornamentals. But clearly, there's many examples where it can have a striking effect. Now, let's start talking about the various elements. Nitrogen is probably the most important, and the one thing I would like for everyone to get out of this seminar is how important nitrogen can be in development of root disease. Nitrogen is unique among a lot of elements because it can be taken up as an ammonium form or as a nitrate form, and this form of nitrogen can have a great effect upon the development of root diseases. Now, I'm trying to minimize my slides that are complicated, but this one here is the one I wanted to show. the difference between a nitrate and an ammonium. Let's say this is a poinsettia plant. Let's say the plant is taking up nitrate. One of the first responses that takes place is that the rhizosphere becomes more alkaline, becomes less acidic, just because of the exchange between the nitrates in there. So if you add calcium nitrate to your plant, if your pH is about 6, it's probably going to go up to about 6.2 after adding in the calcium nitrate. Nitrates also tend to increase the uptake of potassium and calcium. They tend to suppress anions like chloride and phosphorus. As you know, when nitrate goes into the plant, it's got to be reduced to the ammonium form, and these are very expensive enzymes, so it requires energy. So this is a kind of a bottleneck way of keeping ammonium from building up in the plant. When you apply nitrate, it's an effective way. It's why generally we apply nitrates to seedlings, because we have a little bit of a stopgap there to keep ammonium from building up and becoming toxic. Now, if the plant is applied ammonium, many of the opposite things happen. The pH becomes more acidic. You know, if the pH is about 6 and if you add ammonium fertilizers, it'll drop to about 5.7, 5.8. Ammonium tends to increase the anions like chloride and phosphorus, tends to decrease cations. And also, when ammonium is present and there are sufficient carbohydrates in the plant, if the plant's a little bit larger, has been growing, it has carbohydrates that can quickly soak up these ammonium ions and turn them into amino acids so they don't become toxic. So big changes can take place as to whether you apply an ammonium versus a nitrate form. Now, looking at root diseases that are affected by the nitrogen form, some of the classic ones are the Thielaviopsis, the black root rots. And I have a host plant here, Pansy, but as I'll show you in a minute, there are many plants that can be affected by black root rot. And it's been documented in many experiments that if you apply the ammonium fertilizer, you'll get a decrease in disease. Whereas if you apply the nitrates, you'll get an increase. So something, the same amount of nitrogen, just depending on the form it's in, can have a great effect upon the development of this disease. What's interesting is that the opposite is true for Fusarium, and cyclamen and chrysanthemum are two classic problems we have, classic crops rather, that we grow in the Northeast that have Fusarium problems. The opposite's true there. The ammonium fertilizers will increase the disease and the nitrates will decrease it. So this shows you the importance of knowing what the disease is. So you really have to have good diagnostic on all your diseases. So seek out a professional and make sure you know whether it's black root rot or Fusarium wilt. Also, Pythium is kind of a different ball, and altogether is that in here, it really doesn't matter if it's the ammonium form or the nitrate form. It tends to be more of how much there is. The rate is more important. And I'll show you some studies that show both of these examples. Black root rot of pansy, it's caused by that fungus Thielaviopsis basicola. We see it a lot up here in the Northeast because it comes in frequently on plugs and so forth. It can be vectored by fungus gnats, so if it is surviving on your greenhouse floor, it can be brought into your plants. And it tends to cause the stunting of the plant and then the blackening of the root. Here's another example of it on Catharanthus, again showing the yellowing that we see. Another example of it on poinsettia. I don't see this too often, but when it does, it's very devastating, and again causes the blackening of the root. Pythium makes the root kind of dissolve and fall apart and slough off. Black root rot keeps the integrity of the root system, but just blackens it. These are some of the plants that are very susceptible to Thielaviopsis: fuchsia, verbena, petunia, calibrachoa, pansy, viola, vinca, poinsettia, and geranium from time to time. We see that on there. So, if you're having difficulty with any of these plants and you think black root rot is the problem, you might consider looking at this idea of nitrogen form. One of the classic studies that was done about 20 years ago was on vinca. And again, this is the effect of ammonium on black root rot. So over here, we have the amount of disease, the percent disease. So in the presence of just a nitrate form, no ammonium, you can see you got about 75% disease in there. So 3 out of 4 plants are dying if you're applying a nitrate form. But if you could just take the same amount of nitrogen, but increase the amount of ammonium in there, make it half ammonium, you can drop that 75% down to about 32%, and even lower. I wish the study had done completely 100% ammonium just to see if there would be any disease there. Very striking effects that you can reduce that much disease just by choosing the form of nitrogen. Now, most growers, including me, I mean, I go out and I apply fertilizers in my yard and I frequently don't look to see what the form of nitrogen is. But this very fact can go a long way to increase your disease suppression. Now, the reverse is true for Fusarium. As I mentioned, nitrate here suppresses the disease. So you really have to know what the disease is. Asters, basil, chrysanthemum, cyclamen, dianthus, gladiola. These are all the plants that I've worked with up here in Connecticut with Fusarium diseases, and they all tend to respond better to nitrates than to ammonium in terms of suppressing the disease. One of the classic diseases I work on, of course, is Fusarium wilt of cyclamen. Very, very, very difficult disease to control. It takes a lot of fungicide input and so forth to keep this under wraps. But nitrogen can play a big role also in suppressing this disease. Here's an example of the effect of nitrogen on Fusarium wilt of cyclamen. Here, calcium nitrate is very suppressive to this disease. Now, I did this experiment, so I put the same amount of Fusarium in all of those pots. They all have the same amount of inoculum. Here, I applied ammonium nitrate opposed to calcium nitrate. Let me emphasize that ammonium nitrate is an ammonium form. Even though that the anion is a nitrate, the ammonium portion of it kind of dominates it. And this is considered to be an ammonium form. So ammonium nitrate is an ammonium form. And look at the big difference. Same amount of nitrogen, but drastic differences in the development of symptoms and such. And then here's a little graph showing here. Here, when you apply nitrate and you have the Fusarium there, you have a fresh weight that's the same as the non-inoculated. So you really can't even see the difference in fresh weights if you use a nitrate form. If you use ammonium form, you can see that cyclamen really doesn't like ammonium to begin with, but in the presence of Fusarium, you get another drop-off there. So big drastic differences in the health of the plant depending upon the form of nitrogen. I've done a lot of work occasionally with this particular disease, with Fusarium wilt of Hymelus begonias, which pops up every once in a while, and I really don't know what nitrogen form would do there. It's not the same species as we have in cyclamen, but I would imagine nitrates would also be suppressive here. So here's an example where a little bit of research could go a long way to helping growers suppress this disease. So let's review. Ammonium fertilizers: ammonium nitrate, ammonium sulfate, ammonium chloride, and ammonium phosphates. These are all ammonium forms. They all lower the soil pH. They suppress Thielaviopsis, and they're also very effective in suppressing verticillium. Not a whole lot of problems with verticillium in the greenhouse, but in the field with plants like eggplants and strawberry and so forth, I've shown that ammonium fertilizers can suppress this disease. So if you ever encounter a verticillium issue in the greenhouse, again, reducing the soil pH by using these ammonium fertilizers can give you some suppression. Nitrate fertilizers: calcium nitrate, calcium nitrate, potassium nitrate, and sodium nitrate. We don't use this too much anymore, but they also raise the soil pH and they suppress Fusarium wilt. So the one thing I'd like to get you more from this seminar than anything else is the fact that the form of nitrogen can really have a big effect upon these root diseases. Now, what about Pythium? I mentioned that earlier. Now, Pythium is a real problem in many greenhouses. Fungus gnats bring it in. It's usually a resident on most greenhouse soils and comes in most soils. But here, the study that I wanted to bring out was one that was done by Gary Mormon at Penn State, where he took a base fertilizer and he added the basic 20-10-20. He had the base with nitrate, ammonium, and then potassium phosphates, just a wide range of different salts. What was more important is that he applied it at a low rate, an optimum rate, and then a rate that was excessive. And this is in the presence of Pythium, and this is all with Geranium. What he saw in this study here is that at the low rate, he hardly saw any disease. Same amount of inoculum in there, but just by reducing the rate, he was able to keep Pythium under control. The optimum rate, up to about 10% disease. But look what happened when his management got out of hand and he put too much of this fertilizer on. Everything got really high. So the real take-home message here is to control Pythium is to keep your management rates at low or optimum. It's really important because if you go too high there, that's the real damaging to plants that are affected with Pythium. So nitrogen form may not affect Pythium as much as the rate does. So that's something. So nitrogen form is very important with Fusarium, Thielaviopsis, and verticillium, but with Pythium, it's more of the rate. So avoiding the high rates of fertilizers is a great strategy if you're having difficulty with that. We'll go through some of the other elements. Phosphorus, as you know, is very important, and we apply it regularly with our fertilizer regimes. There's not a lot of information that shows that phosphorus can be used to manipulate disease. Plants that are deficient in phosphorus generally are more susceptible to disease. And if you put too much phosphorus on, again, you can get into problems with Pythium. And phosphorus has a way of affecting the uptake of other elements that are important in disease and just overall plant health. So just maintaining the right amount of phosphorus is probably the best strategy, and determining what that is for your plant and is something that you have to determine with your extension agents and such. High phosphorus nutrition can also suppress mycorrhizal colonization. Many of our potting mixes are coming already amended with the mycorrhizae in there, and if we're going to really get the benefit of that, we need to be careful not to put too much phosphorus in the medium, because that can actually suppress the development of mycorrhizae. And mycorrhizae in and of themselves can be very effective in suppressing disease and helping plants protect against stresses. I want to mention briefly phosphonates. These are products that you know of in the literature. They're the salts and esters of phosphoric acid. We better know these things as alliette and so forth. These are potassium phosphite, phosphorus acid, phosphotyl aluminum, and these are actually fungicides. They have very marginal nutritional effect, maybe a slight effect, but they're really their mode of action there is fungicidal and inducing natural defenses in the plants. So you see these things. They're very effective, again, the systems that they work on, but they are really not a mineral nutrition effect going on there. Briefly moving on to potassium. Potassium, like phosphorus, it's probably deficiencies are going to increase plants' susceptibility to disease, and also too much potassium is going to cause salt problems. But where potassium has had an effect, it's always been shown to be the form of the potassium is more important than the amount. Potassium is available to most plants as potassium nitrate, potassium chloride, and potassium sulfate. And most disease suppression usually occurs with the chloride form, the potassium. I'll talk more about chloride later on. So that's something I want to point out to you. There's a lot of conflicting information in the literature about potassium, and it relates more to the form, I think, than the amount. Calcium and magnesium, as you know, lime applications are usually made in levels that far exceed the nutritional requirement the plant needs. And this is probably because calcium is probably affecting the environment, the soil environment, more by raising pHs than supplying any direct nutritional benefit to the plant. Because usually the amount of calcium that goes into the plant is usually not near as much as what we're putting on. But clearly, like with Fusarium, the disease is suppressed by high levels of lime. Example here that was done about 20 years ago down in Florida, actually showing that Fusarium wilt of chrysanthemum could be suppressed by just increasing the amount of lime in the medium. And you can show, I'm dating this slide because in this study they used benamil, which is a fungicide we haven't seen in ornamentals in quite some time. But clearly adding calcium can have a big effect. Also, adding calcium solutions in the irrigation water. Now, this doesn't have necessarily a mineral nutrition effect, but it does seem to have an effect upon Phytophthora infections. Calcium tends to kill or deactivate the zoospores. And here's an example where Peter's 10-20-10 was compared to the same amount where where calcium was added at 10 millimolar, and the number of plants dropped from 11 in this study down to 3, and similarly with the number of dead plants. And so this was really striking, and I really think this is something that we should be exploring a lot more. The role of calcium definitely deserves more attention. So if simple calcium supplements to irrigation water can affect Phytophthora, as these studies suggest, growers need to know better how to use this nutrition in their operations. So we really just need a lot more information. Now, magnesium, again, out of 46 studies I found in this book that we were involved with, there was 18 said that increased disease, 22 decreased disease, and there were 6 there was no effect. So the data is very fractionated right now, and I think this might have to do a lot with many other factors. And so I think magnesium clearly has an effect, but it has to be teased out and understood more carefully. Sulfur, we don't think of applying sulfur too much. It's the oldest recorded fungicide in ornamentals, but recently in Europe, the sulfur nutrition has received a little bit more attention because they have been experiencing sulfur deficiencies because they cleaned up their air a lot more than we have. Right now, there's not a lot of information in ornamentals, but I always caution growers to be aware that sulfur deficiencies and their effect on diseases is a possibility, and we may eventually see it here in the States. Chlorine. I spent a lot of time studying the effects of chlorides for suppressing soil-borne diseases. And chloride's unique. It's only absorbed as the ion, so it's not structurally bound to a metabolite. And it's routinely applied, as at rates equal to the macronutrients. The 10-10-10 fertilizer is actually 10% chloride. So we're putting high rates of chloride on these plants without really knowing that we are. And it's largely ignored as a fertilizer, and I think this is a big mistake because there's many attempts now to look for new sources of potassium as carbonates or sulfates and such. And I think if we start using those and get away from chloride, we're going to have more problems with root disease. These are some of the plants I've worked on or have studied basically that show a suppression to root diseases and some other foliar diseases with chlorides. The only ornamental that I've worked on here was actually cyclamen, and I'll show you a brief study here. This was using salt as an amendment. An old grower told me that he used to throw rock salt into his potting mix, and I couldn't believe it. So I did a study, and sure enough, if you add salt from increasing rates, you were able to suppress the disease. I'm certainly not advocating anybody use this just yet because it can become toxic, as you know, but clearly chloride nutrition has an effect in cyclamens. Now, micronutrients, as you know, micronutrients are extremely important, and I think many of the suppression that we've seen with nitrogen and all the chloride and all those other effects have to do with the uptake of micronutrients. These are key cofactors and they're activators of defense. In our soil mixes, most of our soil mixes are between 6 and 6.5, where micronutrients tend to be less available. This is a classic pH chart showing the micronutrients down here. And if you look at pH 6 and 7, you can see that the availability of these micronutrients really drops off. So making sure that they're available is extremely important. Many micronutrient deficiencies, they disappear when the pH drops. If you start getting down lower. But that can cause problems with plants like geranium, which are very susceptible to manganese and iron toxicity. So again, it's a case-by-case study where we need to know more about what the disease is. Many of the obstacles is that micronutrients, they're not precipitally translocated, so applying them to the foliage will correct a foliar deficiency, but it's really difficult to get those micronutrients down to the roots where they can turn on defense mechanisms. And so this is a real problem that I've been working on, is how do I get micronutrients better down to the roots? So I did some work with nanoparticles I'll talk briefly about. Nanoparticles are very small. If the earth is a particle, a soccer ball is basically a nanoparticle. And so they're very, very small. I did one study on Fusarium wilt of chrysanthemum. I rooted cuttings and then sprayed them with nanoparticles of boron, copper, manganese, zinc. These are oxides, so these are like, almost, these are the solid forms, and then compared them to fungicides. Then we put them out into soil with Fusarium in there. What we found at the end of the season there was that we got disease slowly over time, but we found that that single application to that very young seedling translated into a season-long protection, whereas copper, manganese were equal to the fungicides as far as increasing the weights of these plants. So we're going to be repeating this with a little bit more attention this year. But here, looking at the control, which is pretty ratty. This was a student project, so they really didn't put these plants out very well. I'm a little embarrassed about how poorly they were planted. But you can see what the manganese did. Striking effect. And this is just a small spray to a young plant. I want to briefly end with my talk about silicon. Many of our potting soils that we use now don't have any silicon in there. If you're using natural soil, there's usually silicon available in that, but our potting mixes are pretty deficient in there. And many grasses and many other species respond very favorably to silicon. Here's a shot that was done with just on pasture land, just showing the large effects of silicon. I did a study with my friend from Cornell where we added silicon to Hakonechloa grass, and we went to really high rates. We went, this is grams per liter. I have to translate this into kilograms per hectare, but generally you can see there the tremendous increase in root growth at this 4 grams per liter. This was set up to look at some diseases which unfortunately did not develop in this experiment, so we didn't get disease data, but I just wanted to show you the effect of the silicon on grasses. So if you're growing the ornamental grasses in the potting soil, you might consider a silicon amendment. And also, I know this is on soil-borne diseases, but silicon will also protect against powdery mildew on roses. And a study I did actually many years ago with zinnia, which is a really strong uptake of silicon, got really suppression of powdery mildew in a flooded floor greenhouse that we have here. So silicon's very, very amazing. So in summary, managing these diseases with ornamentals is still in its infancy, and each crop has a nutritional requirement and may need a different fertilizer regime. So growers, we need more research to maximize this information. And so I'm just trying to show you that there's a lot to be learned, and we're just at the tip of the iceberg right now. So I'll ask for questions.
All right, thanks Wade very much. This is Ryan Dixon from University of New Hampshire. That was an excellent presentation, and definitely sounds like you're on the cutting edge with the nanoparticle. So I'm interested in hearing more about that as it develops. We did have one question come in on organic fertilizers. So Wade, do you know anything or have any comments in regards to organic fertilizers and their potential effects on disease incidence?
It's difficult. To my knowledge, most organic fertilizers are going to deliver nitrogen in the nitrate form. So they would be very effective in suppressing Fusarium diseases and so forth. But if you're having other issues and you want to drop the pH, if you want to use an ammonium fertilizer, I really don't know an organic source for ammonium fertilizer. So I'm afraid that's kind of where we're at right now with that.
Okay, excellent. And one more question. You just showed a slide on silicon effects on root growth. Any ideas on why silicon may promote root growth? And did you see more shoot growth in that case too? Or
yes, there was. We saw both biomass increases with the silicon. Grass is just it's not an essential element, but it's strongly a beneficial element, and many plants will actually take up a silicon. Some will only take them up into the roots, and they don't have the ability to translocate it into the above ground. But still, silicon nutrition really needs to be examined more extensively for ornamentals, especially with these ornamental grasses.
Well, thanks very much. So that does it for our questions. Thanks very much.
Ryan, there are a few more questions.
Oh, you do? Okay.
Yeah, there are a few more questions here. So okay. I'm going to read those. One of them asks, in the example of zinnia, powdery mildew was that so incorporated silicon treatment?
Yes, that was actually Agsil, which is a soluble form of potassium silicate, and we were just adding that to the soil as and it could be added in with the irrigation water, and so that was a soil applied treatment. So that was clearly a nutritional effect. I know there's been a lot of interest in using silicone sprays to control powdery mildew as well, but that wasn't the case in this study.
Okay, very good. So the other question is, someone asks, where could you buy silicon?
Silica slag if you were to Google that, I think you would be able to find places around that would actually sell, sell it to you in bags.
One more. There are two more questions. One is, can silicon change the pH of the soil or affect other microorganisms or microbes? Not microorganisms, sorry.
Sorry, what was the question? Would pH do this?
Well, whether silicon will change the pH and affect other microbes.
Yes, I think clearly as you change the pH, you're going to be changing a whole host of things, including the microbial populations. Generally, bacteria tend to do better in alkaline, higher pH soils than in acid soils. Maybe just tweaking it, the amount that we're seeing with the ammonium forms may not be enough to cause big differences in there. But what I have done some research with is that I've shown that by using chloride salts and different forms of nitrogen, that you can change the exudates, and those are the sugars and the amino acids that are leaking out of the roots, and that alone will provide a different community of microbes in the soil.
Okay. The last one here is, does titanium affect or suppress disease?
I'm sorry, I didn't hear the question.
Titanium. It's asking whether titanium does affect or suppress disease.
That's a good question. Titanium, I've been working with titanium nanoparticles, and they clearly will increase photosynthesis and improve health, but I have no data that they will actually affect disease levels yet. But I've only done a few studies, and I don't know too much in the literature where they've been able to show that with titanium.
And the last question is, it says, is doing chili, tomatoes, and onions, can he be able to implement these recommendations on chili? I think it's cherry tomatoes. It says chili, but it should be cherry tomatoes and onions.
Okay, what was the question with chili, tomatoes, and onions? I didn't quite hear it.
Whether it can implement what you were recommending on those two crops.
Well, let's see. Well, I think it would depend on what the disease is.
Yeah.
Yeah. So, if again with onions, I don't know. The main problem I see with onions is Pythium. So there, I think again the amount of fertilizer would be more important. With chili, was it chili tomatoes? Is that what it was?
Yeah.
Yeah. Again, if it's a field crop, you really need to know whether you have verticillium or Fusarium, because if it's verticillium, you might want to drop the pH a little bit. If it's Fusarium, you might want to apply the nitrates to bring the pH up.
Okay. Well,
so you really need to have a good diagnostician there.